Imagine your current PC or laptop trying to run a massive 70 billion parameter large language model. If you don't have a high-end GPU with 48 gigs of VRAM, you're likely watching a crawl of 1 word per second as your system fans scream for mercy. We are stuck in a hardware tax era where the intelligence part of artificial intelligence is directly tied to how much high-precision floating-point math your silicon can crunch. These days, it's sometimes hard to remember that Microsoft has a lot of smart people working for them, but Microsoft's Bitnet B1.58 is effectively a cheat code for physics. To understand why this Bitnet thing matters for your home setup, we have to look at how LLMs think. Traditionally, every connection in a neural network, the weights, is a complex decimal. Multiplying these decimals across billions of parameters is what makes AI so power-hungry. Currently, large language models can be quantized to shrink them down to a size that can be managed on consumer hardware. However, this process is a trade-off, rather like scaling a 4K image to 800 by 600. You lose a lot of detail. In the case of LLMs, they can then be used on more modest equipment, but they effectively become dumber in the process. Bitnet does away with that approach. It uses ternary logic, meaning every weight is restricted to just 3 values, -1, 0, or 1. By shrinking the weights to just 1.58 bits, the math changes fundamentally. Instead of expensive floating-point multiplications, your processor performs simple integer additions. The implications for local LLMs are massive. Because the model is so lightweight, the memory bottleneck that usually kills performance on consumer hardware starts to vanish. A model that once required a $2,000 GPU can suddenly fit into the standard 16 gigs of DDR4 RAM you already have. We're talking about a 70 times increase in energy efficiency and a massive reduction in the memory footprint. Bitnet may arguably be the best news for CPUs in a decade, since it relies on addition rather than complex matrix multiplication. Your standard Ryzen or Intel processor can suddenly run large-scale models at human reading speeds. Because the computational load is so much lower, the thermal output drops. You can run a sophisticated assistant on a fanless laptop or a small edge device like a Raspberry Pi without it melting through the disk. The most compelling part of Bitnet isn't just running a chatbot, it's where that chatbot can now live. Think about true offline privacy. You could have a 100 billion parameter model, something close to the capabilities of the online giants, running entirely on a refurbished office PC in your closet. In edge scenarios like a remote research station, a smart home hub, or even a drone, you no longer need to be linked to a massive data center. The intelligence is baked into the local silicon. It's the difference between cloud AI and ambient AI. Now, the skeptics will ask, yeah, but does it actually work? The research shows that once Bitnet models hit about 3 billion parameters, they match the performance of full precision models. As we scale up, the cost-to-intelligence ratio falls off a cliff. This process may let us move towards a future where large language models aren't just for those with server racks. Bitnet suggests that the next generation of AI won't be defined by how much power we can throw at the problem, but by how elegantly we can simplify the math. It's a move from brute force to pure logic, and it could put world-class AI on the modest hardware already sitting on your desk. Right now, this is in the early stages, but it does work. It can't be used with something like Ollama or LM Studio yet, and the model weights need to be prepared with Bitnet in mind. Once Microsoft proves this technique with larger and more useful 7 billion and 13 billion parameter models, we should really get an idea of where this can take us. Hey, if you got something out of this video, please consider liking and subscribing. And remember, be excellent to each other.